we use the Argand diagram to represent complex numbers. The vertical axis here is the imaginary axis for the imaginary parts of our complex numbers, and the horizontal axis is the real axis for the real component of our complex number. So let's plot a few of these points here. So let's say 2 complex number 2 plus j. So what do we know here? Let's call this one z1. The real part of this number is 2, and the imaginary part of this number is the invisible one that we see here attached to j. So let's just put some text here for our just number line here, and 0 is there. So if we want to place the 2 in the real axis, here it is, the 2, and the imaginary 1 is the vertical one there, and then we get that point. Usually we tend to draw a line that connects the origin with the point. So good to label it 2. That one is our Z1. You see that I didn't write J here because the vertical axis is there just to show the imaginary number, which is the number associated or multiplying the J. So let's do another one. Z2 we'll call 1 plus J2. So same as before, we'll do it in the same plane here. So the real part of our number this time is 1, and the imaginary part is 2. So I'll even just color code that here, the imaginary part there, and the real part here. So real part 1 and imaginary part 2. So let's link those two, and there they are. So this, and draw the line, this is Z2. Let's go and do the next example. So we'll call that one Z3, negative 2 plus J, real part negative 2, imaginary part invisible 1, because it's that invisible 1 multiplying the J. So negative 1 is here, negative 2 is there in the horizontal real axis, and the 1 is the vertical one. So that's now Z3, and let's draw that line, Z3. Then we have Z4, which is negative 3 minus J2, and remember J is sometimes used as I. Some authors will use I instead of J, but it's the same meaning. So real part negative 3, imaginary part that, not 2 actually, but look at what's in front of the J. So let's be careful, negative 2. So negative 3 for X, or horizontal axis, or real part of our complex number, and negative 2. So now we go down in the vertical axis. So negative 3 with negative 2. That's our complex number Z4. And let's draw the line connecting it to the origin. Okay, so yeah, probably the only thing here that was really important was to visualize that negative in front of J makes our imaginary number negative 2. So now just talking about a real, let's call it a pure real or plain real number like 3. If we want to express it as a complex number, we could call this, well, the real part is 3 and there is no imaginary part. So we could say, well, instead of saying no imaginary part, we could say it's 0 associated with the j. And we could connect those two with a plus. So what would happen here? The real component of this complex number is 3, and the imaginary component of this complex number is 0. So let's see how that would look in our two sets of x's here. Same as before, real numbers always horizontal, oops, and imaginary the vertical axis. So we would have 3 in the real axis and 0. So we don't go anywhere here. We just stay exactly where we are there. So this would be, let's call that one Z5. So Z5. And then if you drew the line to link it with the origin, that's where it would be. So Z5 is that number. So -1, if we called this time now another number and we wanted to say, let's say just -1, same as this. So we would say Z6 equals -1. That's a plain real number. So there's no imaginary number here. So no imaginary number with 0 associated with the j. And -1 is our real part. So same as before, we go to the real -1, but we have no vertical movement, so we stay right there. This would be our Z6. And again, if we linked or drew the line connecting it to the origin, it would look horizontal like that. So these are real numbers expressed as complex numbers. What about a pure imaginary number now? One that only had a complex number that only had the imaginary component, something like j2, for example. So let's see how this would look. j2 could be rewritten as, there is no real part, so we could say 0 for that, and we would add the imaginary component, so j2. So how would we do that? Well, same as before, real part is 0, imaginary part is 2, so we know imaginary goes in the vertical axis, so there it is, the 2, and we don't have any horizontal movement, so we stay right there. So if we called this one Z7, that would be the representation of this complex number. And if we wanted to link it to the origin, it would look like that, like a vertical segment. And the last example, just again a plain imaginary number. If we had -j, let's call that one Z8. -j has no real part, so we would call 0, and we would add it to the imaginary number, which is -j. Well, we don't need those two signs, we only need the subtraction then, or the negative in front of j. So what would we say here? Real part is 0, and imaginary part, we have an invisible one here, and we need to take into account that negative sign, so -1. So in the diagram, we would have -1 over there, and we would say there is no horizontal movement because the real part is 0, so we stay right here, and that's Z8. And if we drew the line from the origin, that's what we would have.